So this is what we'll be seeing today, fundamental properties of matrices. So now let's start with the first properties that we have. Okay, we're going to see what is reflection. In short, this is what we see by reflection, a translation of a matrix. Okay, let's see an example. So this is what we have, and then we need to find the reflection of those matrices. Okay, so what's going to happen here, we're going to take the first column, and we're going to place it here as the first row. So we're going to swap column and rows, so it's gonna be A, D, J. Okay, as you can see, this is what we're gonna have on the first row column, the first row, sorry. So we're going to take the second column, and then we're going to do this to apply the same thing. It's gonna be B, E, H, and lastly C, F, J. So this is what we do call reflection of a matrix or translation of a matrix, and we normally represent it with a T next to the matrix. It's gonna be like, if I may say, like we got something like this. Okay, and that symbol that you see here, that's the one that represents translation or reflection of a matrix. Okay, let's see another properties. Now, this is another case, another property that we're going to cover. All zero properties. Whenever you see there is a repetitive zero in a row or maybe column, so what you should know is the answer to this matrix will be 0. Okay, so it could be it could be row or column. If you see all 0 on, let me give you another example. You see, because we have 0 everywhere in this column, so the answer to this matrix is gonna be 0. So this is the case when we see row equal to 0, and here it's a case where a column equal to 0. Okay, we got another case. Okay, and here it's a case where as you can see, the row, we got identical row or maybe a column, but in our case you can see identical row. So the answer to this matrix will be equal to 0. Okay, similar to the second property. This is another property, switching property, and for this one we're going to flip the vertically. So we're going to flip this matrix vertically, so it's going to be something like this. What is in between is going to remain the same. Okay, we're going to flip it vertically, so it's going to give us something J, H, then A, B, C. As you can see, what was on the top goes at the bottom, and what was at the bottom goes at the top. Okay, and then we say this equal to the original matrix. So it's gonna be negative what we had at the beginning. So it's gonna be A, B, C, D, E, F, G, J, H, J, something like this. So this is what we call switching properties. So saying those two matrices are equal. If I can highlight that. So those two matrices are equal. And then you can see the sign is going to change there. This is what we call switching properties. Okay, what we're going to see now, it's a scalar multiply property. Now this time around we're going to use numbers. So then you can see if you check, you look inside the first row, you could see that there is a number that we can remove from that first row, which is, let me just give you an idea. So this is what we add 17, 3, 6. Okay, we divide the first row by 6. Okay, so it's gonna be 6 times 7. Okay, 6 times 3. Lastly, 6 times 6. This is what we have, and because of that we can take out that 6 that you see there. So it's gonna give us 6. Okay, nothing else is going to change. It's gonna be 3, 4, 17, 3, 6. Okay, then we're going to remain with 7, 3, 6. This is the example of what we call scaling. And then as you can see, since in this row we have this repetitive identical number, so that means our matrix will be equal to 6 times 0, and the answer to this matrix will be 0. Okay, just to give you an idea of what's happening. So this is what we call a scalar multiply property. Okay, this is another property that you're going to see, and what you can notice, this is what we have. So we need to figure out a way to separate them. Okay, so, and we're going to apply this sum property. So what we get, it's gonna be A1, A2, A3, C1, C2, C3, D1, D2, D3, plus, okay, it's gonna be B1, B2, B3, C1, C2, C3, D1, D2, D3. So this is what you're going to get. So as you can see, this is what we call sum property. Okay, now we're going to see the property of invariance. Now in this case, we're just going to represent, to show you how you can actually represent what you see on the first row. So what we're going to have, we have something like this: A1 plus alpha B1 plus beta C1. Okay, that's what we're gonna get there. A2 plus alpha B2 plus beta C2. A3 plus alpha B3 plus beta C2. Okay, and then the rest is going to remain the same. This is what you're going to notice. Okay, so just to show you that this block, the first row and the other first row equal, they are just the same. Just to give you an idea of this is the property of invariance. Okay, let's move on to the next property. But before we move on to the next property, I will give you just a simple example of where you can apply this property of invariance. Let's go with one matrix. Okay, I feel like let's just remove this part and move on to the next formula. Okay, and for this factor property, what you should know is the determinant equal to 0 and it's equal to alpha. For this factor property, there's not much to say. Maybe with some example, you will see where you can apply it later. But let's move on to another property. With this property, we call it triangle property. And for some reasons, if you look closely, you can see that there's like a sort of triangle property, okay, of 0. So the way that we're going to represent this matrix, we're going to represent it in this way. It's going to be A1, A2, B2. Okay, so we're going to move this matrix. Okay, so we're going to have something like this. Those triangles that you see there. Okay, so we're going to move the triangle this side. So in some ways, this is how you can apply the triangle property of a matrix. That's the way that you can represent it. As you can see, the triangle move from this corner to the other corner there. This is what we call triangle property. Now we're going to move to another property. Okay, let's go with another property. There is one video that we covered, this determinant of a co-factor matrix. Now for now we're going to I'll just give you a simple example of okay, how we can represent this. I'm going to give you an example, simple one that you can see. C1, C21, C31. You don't need to, I'll give you the formula to get to this C equation, so just bear with me. Okay, so this is what we got. Now the question is, you can see this matrix is going to be equal to this other matrix. Now the question is, how do we go about getting C1, C2, C31 and C33? Okay, now what I will do is I'll copy this block so then I can show you exactly what's going to happen. Okay, Jesse. Now what you can see here, so for the noise, what you can see here, how we can go solve about this last property. Okay, so we do something similar to this. Let me just highlight what we'll be focusing on the first row. Okay, second row, this is where we're going to focus more. Let me just remove this one because it's just repeating the second. Lastly, it's gonna be this one. Okay, so we're going to find a way to work out that's what you see here. Okay, this is the easiest way to do it. Okay, so now this is what we're going to solve. We're going to take this, we're gonna keep this two, we keep them, we keep this block here, those two, and those three there. So I'm going just to remove my comment. So now what we're going to get, there's one thing that I forgot to do, which was this one. So I'm going to write what the leftover. It's gonna be A22, A23, Okay, and the second one is going to be A21, A23, A31, A33. Here it's going to be A21, A22, A31, A32. Now this is what we're going to have here on the first row. Now second row, A12, A13, A22, 33. Okay, next. This one is gonna be if you remove block, we're going to remain with and not to forget about this one, we're going to remain with A11, A13. Okay, so this is what we're going to remain with. Okay, and what you see here, the first block we're going to call it will be equal to C11. So let me just adjust. Okay, and this is how we get we find those C1, C11, C21, C23. Okay, and it was from this block. If I can just repeat that. So this is where we have C1, and this is where we have C12, C13, C21, C22, C23, C31, C32, C33. So these are just the properties, and just to give you an idea of these properties and the representation you find at the side. Okay, so it was just to give you an idea about the properties of matrices. Now we're going to move on another topic.